All right, class. So we are going to move from powers of 10 to scientific notation. And you're going to recognize a few things that we just finished up with powers of 10. So these are your notes. I want you to fill them in. I want you to highlight, and I want you to add anything that I add and delete anything that I delete. And hopefully you will come to me if you have any questions. The good part about these videos is you can hear me as many times as you need to hear me. If there's something that you miss, you can rewind it or you can pause. Maybe you need a break. So, good part about having the videos is it's not just a one-time situation for you. Okay, so we are going to, it would be very helpful if we started with the first page, and apparently I stapled mine backwards. All right, who knew, right? All right, so we're starting with scientific notation notes. These are our notes, and we're going to have some practice after this as well, okay? So first thing, we have to know what scientific notation is. How do you write it? Okay, so scientific notation is a way of expressing numbers that are too big or too small. Basically, too long to write, or, well, that's essentially what it is. When they're too long to write, we're going to shorten it up. Standard form is what you have already been doing since you learned how to count. Standard form is your typical way of writing numbers. Again, highlight, fill in all the blanks. All right, so we have two forms that we're going to be converting back and forth between. And again, scientific notation is the tricky part, so you have to know how to write it first. So we're going to discuss how to write a value in scientific notation. Okay, so we're going to break this next section, and they did a very nice job for us right here. So your first factor, and vocabulary is really important this year. Factor means a number that is in a multiplication problem. This is the first factor, 2.8. This is the number that is at least 1. It can be 1, but at least 1. But less than 10. At least 1, but less than 10. It may or may not be a decimal. So there might be a decimal point after that first number. So just kind of like this is at least 1, but less than 10, which is why that decimal point is right there. Okay, so this makes it a decimal value, but it makes it less than 10. If I didn't have that there, it would be 28, and that would be too large. That would kind of defeat the purpose of writing it in a shorthand way. All right, your second factor, again, factor is an answer to a multiplication problem. So here is your multiplication. That's your multiplication sign. Okay, so you're not going to see any more X's. And if you do, it's very seldomly. So first factor, second factor. Your second factor is what we just finished talking about. We just finished up your mastery check. Your second factor is always a power of 10. All right, so your power of 10 is really important. The exponent tells you how many times to move the decimal points. So do me a huge favor. Please do not use your calculator, and besides, you're not allowed to. This is, again, a non-calculator section of your SOL test. So the sign of the exponent, this is the trick. It's the sign of the exponent. And we had just got done talking about positive and negative exponents, okay? So we had powers of 10 with negative exponents, powers of 10 with positive exponents. So that exponent tells you which direction to move the decimal point in. So what I mean by that, since this is a positive, you're going to want a large number. If it was a negative, you're going to want a small number, meaning a teeny tiny 0.00 something, blah, blah, blah. Okay, so this is just how to write it in standard notation, or sorry, excuse me, back it up. This is how you write it in scientific notation. And what we're going to do now is we are going to move on, changing it from standard to scientific. I'm going to do a couple with you, and then you're going to have some practice on your own. All right, so again, we are going from standard form to scientific. This stuff right here in these arrows will make more sense as I talk through each example. So your first example, you are going to be changing. So this is another word is convert. Okay, so we are converting from one to another. And in this case, standard to scientific. So this is how you normally write your numbers, and this is the shorthand way. So we have 420,000. My strategy is I box up every non-zero digit, which is 4 and 2. If there's a 0 in between, I would box that up too. So if it's trapped in between non-zero digits. And then I'm going to take and draw a line after the first number. That's going to tell me where I need that decimal point moved. Okay, so in this case, between this point and this point, how many hops, how many spaces did you move? Okay, so you're going to, in this case, move that decimal left, move left, and drop the zeros, which means I'm going to have 4.2 because I need it at least 1 but less than 10. And I'm going to multiply that by 10, and we said it was 5, so it's 10 to the 5th power. So I'm going to leave this one blank for you. I would like you to attempt this one on your own. And then I'm going to skip down to this one. Okay, so you're going to notice the first two are similar and the second two are similar. So this is a very large number. This is a very small number. But if you notice, they're both long. They have lots of digits. So this one down here, again, I'm going to box my non-zero digits. Only this time they're on the opposite side, right? And then I'm going to put a line after my first number. And that's going to tell me to move my decimal from here to after the 8. So I'm going to, in this case, move right. And I'm going to drop the zeros. So in this case, how many times did I move? Well, I should have moved 3, but I need to put all of my non-zero digits. So I'm going to put 8.97. And I'm going to multiply that by 10, and we moved 3, but this time it was a teeny tiny number. So that's where the negative exponent comes in. Again, I'm going to leave this one blank for you. I want you to try it out. Okay? If you are confused, you're thrown off, you don't know where to begin, this is a good time to pause the video and come see me. Okay? All right, if you are all set with this and you're confident in what you're doing, I would like you to go ahead and move on to converting from scientific to standard. Okay, so that means you're going to flip your page. All right, so again, we are continuing on with scientific. And these arrows will make more sense when I give you the examples. That's how I feel anyways. Some of you might actually get more out of it. All right, so this time we're going to convert from scientific notation to standard form. Again, how to change, okay, and we are converting. So this time we are going to find our decimal point, which thank goodness it is there for us. Sometimes it isn't, but if you notice, this is written correctly, so I can begin, right? I have a number at least 1, less than 10, I have a multiplication sign, and I have a powers of 10. And you already know with a power of 10, with a positive number, that positive 5, you are going to have a large number. So in this case, it's going to tell me to move 5 places. And I'm going to move 5 places right because it's a big number. So I'm going to move 1, 2, 3, 4, 5. And that I'm going to fill in zeros. And you count to put your comma in. So it's 750,000. So if I have 7.5 times 10 to the fifth power, it is equal to 750,000. Again, I'm going to leave the next one blank, and I want you to try it out. Okay, third example. I have 4.2 times 10 to the negative third. And let me remind you, you can pause this video anytime you need. So 4.2 times 10 to the negative third. We know that's a negative number, which means we're going to have a teeny tiny number. So instead of moving right this time, I'm going to move left. And I'm moving left how many spaces? I'm going to move left 3 spaces. So in this case, I'm not counting the 2. The 2 is just kind of there. It's a friend hanging out. I'm going to go 1, 2, 3, and I'm going to fill in my zeros. I don't need one right here, but most of the time we put one there. So this is just a placeholder. Again, I would like you to try the last one on your own. And then you have practice down below. So this is your goal right here to work on these. And again, if you are getting to the point where you need to rewind, you need to pause it, you need to take a breath, you may do so. And I would love for you to finish these practice problems right here. And then I would love for you to come get checked by me. Okay? It's an easy moment. And that's a lot. I know this video is quite lengthy. I don't usually try to make them go over 10 minutes. So I will do better. But this topic is a lot. So that is kind of understandable. All right. Well, happy finalizing scientific notation, and hopefully it goes well. And if not, it's okay. It's day number 1 with it. All right.